In this next example, I'm going to have a combination of both finding an LCD and then trying to cancel common factors. If I write big brackets around the numerator here and big brackets around the denominator, you can see that what I could have done over here is I could have written this out as a half plus 3/4, and now I could change my divide line to a divide sign, and the number that came after is the one below, and that is divided by 4/5, and that is minus 3/10. Now looking at each bracket separately, you can see that it requires an LCD. But what I'm going to ask is that if you see a compound fraction like this, instead of finding just the LCD for the left-hand side and then separately for the right-hand side, we're going to find the LCD for all of those factors in the denominators. Now you can see that you've got a 2, a 4, a 5, and a 10. And if you get the LCD of all of these numbers, you have to have the highest degree of each. Well, 2 squared is greater than 2, so you need 2 squared. You need the 5, and as 10 is made up of 2 and 5, your LCD is going to be 20. Now using the LCD, I'm going to find a common fraction for my first bracket. Let's get that straight. If I want my LCD to be 20, then I have to say to myself, well, what did I do to 2 to get to 20? You times that by 10. And so its numerator of 1 also must be multiplied by 10. To get from 4 to 20, you multiplied by 5, and 3 times 5 is 15. I still have a bracket on the left that needs further simplification, and now I'm going to try and get a common denominator for the bracket on the right. Getting a common denominator on the right, remember our LCD is going to be 20. To get from 5 to 20, I times by 4, and 4 times 4 is 16. To get from 10 to 20, I times by 2, and 3 times 2 is 6. Now if I add my numerators on the left-hand side, I'm going to get 25 all over 20, and this is going to be divided by 10 all over 20. Remember our new rhyme, which is going to be times and tip the fraction after. So in this case, the first fraction was not prefixed by divide, so it stays exactly as it was. Change your divide to a times and tip the fraction after. You can very nicely see that there is a 20 in the numerator and a 20 in the denominator that can be cancelled, and so your answer is 25 all over 10. Obviously, by further simplification, you can find that this is going to be 5 all over 2. Now if we go back to the very first line of our sum, and working with an LCD that would work for all of the fractions, I find that the two denominators fall away because they cancel out with each other. And you're going to be left with an answer from your first numerator divided by the answer for your second numerator. Let's try this with an algebraic fraction. In this example, I am only going to use my denominators to find my LCD, and I know that the LCD must be the most of each type of factor. As x squared has a higher degree than x, I choose that, and likewise I choose y squared. Now because I've got an LCD for both my numerator fractions and my denominator fractions, the two denominators are in fact going to fall away, which means that I'm going to be left with the following. If I had chosen an LCD of x squared, y squared, and my first denominator had just been x, its numerator would now have to be xy squared. And the second numerator has to have the factors of x squared y. Now moving into the denominator factors that I'm going to have, in the first term, there was an x squared, so all that remains is for it to get the y squared factor. The second denominator had the y squared, so it must get the x squared denominator. At this stage, I'm going to simplify and see if I can cancel common factors. In my numerator, there is an x that is common and a y that is common, so I'm going to take that out as the highest common factor. By taking out that as the highest common factor, I'm left with y in my first term and x in my second term. In my denominator, you've probably recognized that you have a difference of two squares. And if I factorize that, I'm going to get y plus x and then y minus x. Now you like working with x's before y's, but be very careful that when you split this into your difference of two squares factors, the y term came first, so it must still come first in the bracket. The x squared term came second, and so as difference of two square factors, you cannot just willy-nilly change the order. Now if you take a look carefully, you can see that there is a y plus x factor, one in the numerator and one in the denominator. And when I cancel those, I have my fully simplified fraction, which is going to be xy all over y minus x.